For Chapter 10, Section 4, we're going to talk about radical equations and how to solve them. So you're going to be dealing with these expressions that still have radical signs, but instead of us just simplifying numbers or like variables with exponents underneath our symbols, we're going to have a variable involved, and we're going to want to solve for the value of that variable. When you're doing problems like this, you're going to want your radical piece to be isolated. So for this first example, it says the square root of x plus 3, and then we have plus 7 equals 17. I need to get the x plus 3 underneath the square root. I need to get that by itself. So I need to move this plus 7 over to the other side first. To do that, I'm going to subtract 7. So just use your algebra skills to solve that equation for getting those terms over on the same side. So I'm going to bring down my square root of x plus 3, and then 17 minus 7 is going to be a 10. Now that I have my radical on one side of the equation and I have my number on the other side of the equation, I need to get rid of the radical altogether. Because this is just a square root, what I'm going to do to both sides is I'm going to square them. Remember in the past when we've dealt with these radicals, if you see that the number with a power is the same as the index of the radical, that they're just going to cancel each other out, which is why I'm squaring both sides here. So on the left-hand side, when I square that, basically this square root sign is going to cancel off with that 2 out front, and the x plus 3 is just going to come out. And you get rid of that radical sign altogether. Then we have equals 10 squared, which would be 100. And then we're going to solve for x by subtracting 3. And so we would be left with x equals 97. And if you wanted to check your answer, you could. You could come back up here to our original equation. We could do that 97 plus 3 underneath the square root. Then we have plus 7 equals 17. 97 plus 3 would be 100. So we'd have the square root of 100 plus 7 equals 17. Well, the square root of 100 is 10. So 10 plus 7 would be 17. So it does check out, and that just kind of lets you know that you did the process correct. Now you may see some examples where you have radicals on both sides of the equal sign. So in this case, I don't really want to try to combine them because they're not like terms, so I can't simplify them by adding one or subtracting one from the other. So instead, what I'm going to do is just go ahead and start by getting rid of the radicals by squaring both sides of my equation. On the left-hand side, that square root sign and the 2 for the exponent will cancel, so we bring out the x minus 6, bring down the equal sign. When you square this side over here, you have to square both the 3 and the 5 underneath the square root sign. So 3 times 3 would be 9, and then when you square that square root of 5, it's just going to become a 5, because that's going to come out of the square root sign, just like the x minus 6 came out of the square root sign. So then I have x minus 6 equals 45. So then I would add 6 over, and I would get x equals 51. And again, you could check your answer. You could do 51 minus 6 equals 3 square root of 5. 51 minus 6 would be 45. In which case, then you look for a group of 2 in 45. So 9 times 5, 9 would be 3 and 3. And so that 3 comes out, the 5 has to stay, and so that does equal the 3 square root of 5 that we saw on the other side. So again, it checks out and lets you know that you did it right. So I want you to pause the video at this point and do this practice problem and this practice problem, and then come back and watch for the solution. For this first practice problem, you needed to move the 4 first. So I would have subtracted 4 from both sides. So we have the square root of x minus 2 equals a negative 1. Then I would have squared both sides of my equation. So I have x minus 2 out of the radical now equals 1. Then add the 2 over, and you should have gotten x equals 3 for this first one. For this practice problem, you have to start by just squaring both sides of the equation because it doesn't have like terms that we could combine. So on the left-hand side, you'll have an x plus 4 equals 2 squared would be 4, and then that 3 is going to come out of the square root sign, so we have 4 times 3 here. So we have x plus 4 equals 12. Subtract 4, we get x equals 8.